Hey, Wildcat, so we're going to 5, going the equidistance equation of a parabola. Using graphing technology to graph each equation and its inverse, determine the vertex and the axis of symmetry of each graph. All right? Now, let me open up Desmos. Graphing calculator. So let's go ahead and graph x squared equals 8y. Now, the vertex is 0, 0. So the axis of symmetry is x equals 0. Okay, let's take a look at the second graph. All I need to do is put a negative in front of the x squared. The vertex is 0, 0. So the axis of symmetry is x equals 0. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. All right, you can mark off this page. Take a look at this. You can mark off this page. All right, activity 5.1. A parabola has a locus of points. Your previous parabolas as quadratic functions and recognize the equation of a parabola as y equals x squared. You analyze the equation and graph parabolas based on the position of the vertex and the additional points, determined by using x values on either side of the axis of symmetry. Recall that when a plane intersects one nap of a double nap cone parallel to the edge of the cone, the curve that results is a parabola. Take a few moments to look over this picture. In this lesson, you will explore a parabola as a locus of points. To determine more information about the parabola, a locus of points is a set of points that share a property. A parabola is a set of all points in a plane that are equidistant from a point from both a focus and a directrix. The focus is a point which lies inside the parabola on the axis of symmetry. The directrix is a line that is perpendicular to the axis of symmetry and lies outside the parabola and does not intersect the parabola. All right, let's take a look at the next page. All right, now we're going to mark off this portion, this portion, this portion, but we're going to look at this. The concavity of a parabola describes the orientation of the curvature of the parabola. A parabola can be concave up, concave down, concave right, or concave left, as shown. The vertex of a parabola is the point on the axis of symmetry which is exactly midway between the focus and the directrix. It's also the point where the parabola changes direction. All right, let's take a look at the next page. All right, we're going to mark off this page. All right, activity 5.2, equations of a parabola. The parabola shown is defined such that all points on the parabola are equidistant from the point 0, 2, and the line y equals negative 2. One point on the parabola is labeled as x, y. Determine the equation of a parabola by completing the steps. Let d1 represent the distance from x, y to 0, 2. Write an equation using the distance formula to represent d1. Simplify the equation. First off, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, where in this case x1 equals 0, y1 equals 2, x2 equals x, and y2 equals y. Okay, so let's go ahead and complete the distance formula. Okay, so x2, which is x, minus x1, which is 0 squared, plus y2, which is y, minus y1, which is 2, squared. Okay, which simplifies to be x minus 0 squared is x squared plus y minus 2 squared. Okay? All right, let's take a look at B. Let D2 represent the distance from xy to the line y equals negative 2. Write an equation using the distance formula to represent D2. Simplify the equation. So, we have x2, well, x1 is x, y1 is negative 2, x2 is x, y2 is y. So we have x minus x squared plus parentheses y2 is y minus a negative 2 squared. Well, x minus x is 0 squared plus y minus 2 is y plus 2 squared, which simplifies to be y plus 2 squared. Now, what do you know about the relationship D1 and D2? The two distances are equal to one another. Write an equation for the parabola using question 1, parts A through C. Simplify the equation so that one side of the equation is x squared. I will explain 1D on a separate piece of paper. All right. So step 1, we're going to set D1 equal to D2 and simplify. Now, since they're both square roots, we're going to square both sides. Now, the squared cancels the squared. You're left with x squared plus y minus 2 squared equals parentheses y plus 2 squared. So then that's x squared plus y minus 2 times y minus 2 equals y plus, excuse me, times y plus 2. Excuse me. So then that's x squared plus, that's 4, y times y is y squared. Y times negative 2 is negative 2y. Negative 2y plus 4 equals y squared plus 2y plus 2y plus 4. So then that's x squared plus y squared minus 4y plus 4 equals y squared plus 4y plus 4. Now, I can subtract y squared from both sides. Cancels, cancels. I can also subtract 4 from both sides. Cancels, cancels. That leaves x squared minus 4y equal to 4y. And then I'm going to add 4y to both sides. Cancels, you get x squared equal to 8y. All right, go ahead and finish that up. All right, let's take a look at the next page. The general form of a parabola with the vertex of the origin is an equation of the form x squared plus dy equals 0 or by squared plus cx equals 0. The standard form parabola with a vertex at the origin is an equation in the form of x squared equals 4py or y squared equals 4px. Excuse me, where p represents the distance from the vertex to the focus. Write the equation of the parabola from question 1 in the general form and in standard form. The standard form of the equation is x squared equals 8y. The general form of the equation is x squared minus 8y equals 0. What are the coordinates for the intercepts of the parabola? The x-intercept of the parabola is, and that goes back to our graph, which I believe we have here. Our x-intercept is 0, 0, and our y-intercept is 0, 0. Okay. Describe the symmetry of the parabola. The parabola is symmetric about the y-axis. Calculate the coordinates of the point that has an x-coordinate of 4. So we're going to substitute x equals 4 into x squared equals 8y and solve for y. So x squared equals it. That's why we're going to plug 4 in for x squared. So that's 4 squared equals 8y. That's 16 equals 8y. So 2 equals y. So the point is 4, 2. All right, let's take a look at number 6. Determine which other point on the parabola has a y-coordinate of 2. Explain your reasoning. We're going to substitute y equals 2 into the equation x squared equals 8y and solve for x. So we have x squared equals 8y, y is 2, so x squared equals 8 times 2, so x squared equals 16. Take the square root of both sides. X equals plus or minus 4. So x equals 4, x equals negative 4. So the point is 4, 2, and we should probably write that point as negative 4, 2. Okay. Number 7. Calculate the coordinates of each point that has a y-coordinate of 4.5. So we're going to substitute 4.5 into x squared equals 8y and solve for x. So x squared equals 8y, y equals 4.5. So guess what? That's x squared equals 8 times 4.5. Carry our work, so that's x squared equals, I don't know off the top of my head what is that calculation. So we're going to go to scientific calculator. 8 times 4.5 is 36. So take the square root of both sides. X equals plus or minus 6. So the points are 6, 4.5 and negative 6, 4.5. All right, go ahead and finish that up. You can determine the points in the parabola that have a y-coordinate of negative 4.5. So we're going to substitute y equals negative 4.5 into x squared equals 8y and solve for x. So that becomes x squared equals 8 times negative 4.5, which is x squared equals negative 36. Take the square root of both sides. You get x equals the square root of negative 36. The square root of a negative number is an imaginary number, so there are no points that have a y value of negative 4.5. All right, let's take a look at the next part. Sketch the parabola using the table of values. So 8 negative 4, 2 negative 2, 0, 0, 2, 2, and 8, 4. What is the relationship between the axis of symmetry? The parabola has a horizontal orientation. Its axis of symmetry is the x-axis represented by the line y equals 0. What is the vertex of the parabola? That is that point right there, which is 0, 0. Excuse me. How is the concavity of the parabola related to the orientation of the parabola? A parabola that has a horizontal orientation is either concave left or concave right, and the graph parabola is 9a is concave right. All right, let's take a look at the next page. Consider the parabola representing the equation x squared equals 9y. Complete the table of values for the equation. Sketch the parabola using the coordinate from the table. So when x is negative 6, so we can go to Desmos.com, graphing calculator, and then x squared equals 9y. So when x is negative 6, I'm going to click right there, and that is 4. When x is negative 3, it looks like 1. 0, 0. And we know that this is symmetric, so this would be 1, this would be 4. So negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Negative 1, 2, 3, 1. 0, 0, 3, 1, 2, 3, 1. 4, 5, 6, 1, 2, 3, 4. All right. What is the relationship between the axis of symmetry? The parabola has a vertical orientation. Its axis of symmetry is the y-axis represented by the line x equals 0. The vertex of the parabola is right here, which is 0, 0. How is the concavity of the parabola related to the orientation of the parabola? A parabola that has a vertical orientation is either concave up or concave down. The graph of the parabola is concave up. The standard form of parabola with the vertex at the origin is the equation of the form x squared equals 4py or y squared equals 4px. What is the standard form of the parabola with an axis of symmetry along the y-axis? If the axis of symmetry is along the y-axis, then the standard form of the parabola is x squared equals 4py. What is the standard form of parabola with an axis of symmetry along the x-axis? If the axis of symmetry is along the x-axis, then the standard form of the parabola is y squared equals 4px. What is the equation of the axis of symmetry for a parabola with a vertical orientation? The equation of the axis of symmetry for a parabola with a vertical orientation is x equals 0. Excuse me. What is the equation of the axis of symmetry for a parabola with a horizontal orientation? The equation of the axis of symmetry for a parabola with a horizontal orientation is y equals 0. Is the concavity of a parabola with a vertical orientation described as concave up or concave left or right? The concavity of a parabola with a vertical orientation will be described as either concave up or concave down. Is the concavity of a parabola with a horizontal orientation described as concave up, down, or concave right, left? The concavity of a parabola with a horizontal orientation would be described as either concave left or concave right. All right, go ahead and finish it up and have a wonderful Wildcat day.